So in the previous few lessons, you people have seen some basic things about functions, their classifications and standard functions as well. In this one, in fact, in the next few videos, I'm going to talk to you about some special functions. So starting with this one, which is of even and odd function. So before we move on to the mathematical definition, let's just see some basic things here. Suppose you know that cos 60 is half. What if I ask you what is cos of minus 60? You will say that this is half because cos minus theta is nothing but cos theta. But on the other hand, if you say that sine 60 is root 3 by 2, sine of minus 60 is nothing but minus root 3 by 2 because sine minus theta is nothing but sine theta. So what do we observe from here? If you just replace theta by minus theta, the modulus is the same, but in the first one, it is having the same sign, whereas in the next one, it's having the opposite sign. This particular observation will actually give rise to the concept of even and odd function. So for even and odd function, we will see that fx is actually basically the same thing as minus f of minus x for all possible x's when you have for even function. For example, let's consider fx equals to x squared. Let's take the input as minus x. What happens? F of minus x will be minus x whole squared, which is x squared, and it's same as fx. But for odd function, this will actually release the minus sign. Consider this gx as 1 by x. What if I put this gx equals to, just x equals to minus x here? You will see that the minus sign will come out. So these are the things about even and odd functions. Now we have taken the example of x square and 1 by x. So what I'm going to do is show you some properties here. Look at the graphs. You will see that for any even function, the graph will be symmetric to the y-axis because the y-axis is x equals to 0. On the right, we have x positive. On the left, we have x negative. So if you have the same absolute value, you will have the same output. So whatever you observe algebraically is beautifully represented geometrically as well. Take any odd function, you will see that this is going to be symmetric about the origin. All right, so these are the properties. Few more things. So these can be proved easily. So if you remember them very well, just try and understand the essence. The proofs are very simple. So you can definitely try them on their own. The product of two even functions will be even. If you take the product of two odd functions, that will be even. Now, both the odd functions will release negative signs. So them together will actually absorb the sign and it will become an even function. If you add or subtract two even or odd functions, you will actually have the same thing preserved. And the product of an even and odd function will be an odd function because one will release a positive sign whereas the other one will release a negative sign. So together this will be odd. Now a few more things that you need to notice. Let's look at all these examples here. We have taken some functions. Just try and replace x by minus x. Whatever output you get, obviously you notice whether it's f of x or minus f of x or gx minus gx, etc. Unfortunately, it will not come out to be minus fx or fx. It's neither going to absorb the sign nor release that. So these are neither even nor odd function. So we can have functions which are even and odd. Those are the classifications, but it's not necessary that every function can be categorized into these two. Similarly, if I look at the zero functions, say take fx equals to 0, you will actually notice that this is both even and odd. So you can have functions which are neither, whereas you can have functions which have both the qualities. So don't just think that this will cover the entire thing or the existence of the one thing will actually guarantee you the presence of the other. Now that we understand the basics and properties, let's take a couple of examples. Starting with this one, you have to judge whether it's even or odd. So what was the basic algorithm here? I'm going to start with f of minus x. Just for this one, put x equals to minus x and see how the outcome will come out to be. So this is x squared minus mod x, which is same as fx. Now applying the definition, you will say that this is an even function. There's very interesting thing that you can notice. If you look at x squared individually, it's an even function. And mod x is also an even function. So this function, being the difference of two even functions, will also be even. So if you actually understand these kind of properties, you don't have to work out the rest of the sum, and this will help you to save your time and build some good concepts. Next one, you have to find out the value of k such that f is an odd function. Now it's said that f is an odd function, so let's apply the basic thing we know about odd functions. Fair enough. Put all the values here. A lot of things will get cancelled, like minus x cubed, minus 2x. So you will be left with this one, for which you will have k equals to 0. If you look at the original thing here, this is very important. This part is odd. This is also odd. Now x square is even. You cannot do anything about this minus k. So you actually need to remove this in order to make it an odd function. So these kind of observations will actually help you to strengthen your concept. So I hope at the end of this video, you understand the concepts and properties as well as some applications. So in the next two videos, I'm going to talk to you about two more special functions. So stay tuned for your next lessons.